Okay, let's deal with geometric series. And a geometric series is different from a geometric sequence because we're going to be adding them. That's the difference between a sequence and a series. A sequence would have commas in between them, for example. You don't have to write this down. But 2, 5, 8, 11, obviously we're adding 3 every time. But this is a sequence. Whereas if I said, now add these together, then 2 plus 5 plus 8 plus 11 plus whatever, and we'd stop it off at some point. That would be a series, and of course this one would have to stop at some point. Otherwise we're adding a bunch of numbers that tends toward infinity, and the answer would approach infinity. So let's get started with the first problem. It says you deposit $100 in January, of course that being the first month, and we're going to keep that in mind as we go through this. So we deposit $100 in January. So $100 here, and this is month 1. I'll call it M1. You can call it A sub 1, call it whatever you want. And then we're going to add 12% more than the previous month each month. Now I know I just said the word add. However, it's really going to turn into geometric because we're going to be multiplying, and we've done something like this before. But if we add 12% of 100 to 100, we obviously have 112. And if I may, for just a moment, I want to kind of bore you to death and tell you where that came from in case it's not nearly as obvious in the future. And this will help us generate some of the other numbers in our list as well. So if I have $100 and then I'm going to add 12% of $100, then that's where the 112 comes from. So the next number isn't something that we can necessarily do in our head very easily, but we can do 112 plus 12% of. When I say of, I hope you notice that I'm hitting times multiplication. So 12% of 112, and it's this. So 125.44 is our next one. Now in just a minute, we're going to, 125.44, we're going to run into numbers that are going to have more than 2 decimal places, and we're dealing with money, so we would have to round it off. But anyway, we'll stop there actually, because we know it goes on and on and on and on and on. And it actually doesn't go on forever. It says how much will you have deposited by the end of the year. So we want to know what the sum of a certain number of these is. We're trying to find what the sum is, so we're going to add this, plus, and then we're going to keep on adding until we get to the end of the year. Well, this is January, February, March. I did M for months, by the way. And we want to add all the way to M12. Because we need to find out what happens in the 12th month, in December. Now, with an arithmetic sequence, and this is not arithmetic, with the arithmetic sequence, don't you write this down. This is a review, okay? Because this does not apply to this problem. But with an arithmetic sequence, if I wanted to add the first 12 terms, then I would need to know, obviously, how many I'm adding. And I would need to know the first term, and I would need to know the 12th term. Well, obviously, the number I'm adding is 12 over 2, and then the first term and the 12th term. And that's the way this formula works. But again, this is not arithmetic. This is geometric, and there's a different formula. It is on your formula sheet. But the difference between this one and arithmetic is that you don't need to know the final term. It's really cool. There's a really cool formula for it. So the sum of the first n terms of any geometric series is going to be A1 1 minus r to the n, we'll put that in parentheses, all divided by 1 minus r. Now, I'll go ahead and warn you, when you see it written, it normally looks like this. However, I will warn you that when you type it in your calculator, that needs to be in parentheses. So generally, when I write it, I like to put the denominator in parentheses. So notice that nowhere in here does it say, find out what the 12th term is. It's just one of the quirks of the formula. So what we do need to know, though, is our first term, which is obvious, it's 100. And then 1 minus r. Now, we don't know what r is. Now, the reason I picked this example to do is because there was 2 reasons, actually. I wanted us to be able to find r 2 different ways. So those are my 2 reasons. One way, of course, is the old-fashioned way where we say, well, I don't know what r is. And so I come over here and I say, well, first of all, and I'm going to just guide you through my thinking on this. If I am truly adding the same thing every time, then I added 12 here, and I would add 12 here, but if I add 12 to that, I don't go here. So that rules out arithmetic. We know it's not arithmetic. If it's truly geometric, then it would be 112 divided by 100. You can do it in your calculator, but I'll save you the trouble. You should be able to do this in your head. You get 1.12. And sure enough, that's what we're multiplying by every time. So here's the other way of looking at it. When we did it in our calculator, and again, this is what it looked like. What we really had was 1/112 and then 12% of another one. So it's the same thing as if we would have done 1.12 times 112, and it'll give us the same thing. So we can do that last answer times 1.12, and it gives us the same thing. Basically, we have 100% of something, and then 12% more. And since we're doing, you don't have to write this part down, but if we're gonna, since we're gonna do it this way, we can have 100% of something. Since we're adding 100% and 12%, we're really going to be adding, move the decimal over 2 places, 1 plus 0.12, and so it's 1.12, and that is our common ratio. Okay? I just wanted to throw that out there. There's multiple ways of looking at it. 100% plus 12% makes 112%. So that's where the 112 comes from. 1.12, oops, messed up, to the n. And n in this case is going to be 12, because we want to know what happens within the first year. We're going to divide it by 1 minus 1.12. And then we'll type that in the calculator. Let me show you how that looks. Parentheses and everything, you can figure it out. You're smart people, but we'll do 100, parentheses 1 minus 1.12 to the 12th power, divided by, in parentheses, 1 minus 1.12. When I hit enter, we're going to get a crazy decimal. This deals with money. So we're going to round to 2 decimal places, and there we go. We have deposited $2,413.31. So we'll round to 2 decimal places when dealing with money. Generally, I'm a 2 decimal place kind of guy anyhow. So filling all that in again gives us 2413.31. Now we could have wasted our time, figured out every single one of these and added them together. We might actually would have been off by a few decimal places considering some rounding error. However, that's okay. That is our final answer. It's close enough, within a few pennies. There it is. Okay, well the second problem says how much we have deposited by the end of the second year. And if we're going to deposit it by the end of the second year, let's draw a little line right here. We're going to separate these two problems. So one of them is going to be after year 1, which would be 12 months. And then same problem, but now it's going to be at the end of year 2, which is 24 months. So don't look at it and say, oh, 2 years, n is 2. No, we're depositing monthly, so be careful with that. So same process, same formula. I'm going to skip writing this over again, but we're going to jump straight to here. So the first term is 100. 1 minus 1.12 to the 24 now. 24. This should end up being a considerable amount of money. 1.12 on the bottom, 1 minus 1.12. And then we'll type that in the calculator. Actually, we're not going to. I just want to show you something real quick. You probably know this. This was the last thing I typed. If I hit second and enter, pulls up the last thing I typed. I can go back and edit that because that's the only change right there. There should be a 24 instead. Boom, there we go, $11,815.52. Sounds nice. That's why you should save your money, folks. Save it while you make it. Don't spend it. You never know when you're going to need it. 11,815.52. There we go. Seriously, save your money. You can write that down. Okay, we've gone through the first 2 problems. And they weren't too terribly difficult. As long as you know how to use the formula, you'll be okay. I want to point out something, though, because we're going to go somewhere with this in just a minute. This is what's called a finite series. It's finite because it ends. I'm going to deposit money for 12 months, and I stop. And I'm going to take the total of those 12 months, stopping right there, or 24 months, and it stops. There's a big difference, a huge difference, between a finite series that stops and an infinite series that keeps on going. Okay? So erase the board and we'll jump to the third problem. We're going to add the first 20 numbers in a sequence in which the first number is a 60 and each number is 4% greater than the previous number. That horizontal black line is not wanting to erase. Why in the world did I draw it? I don't know. Okay, so the first term is a 60. And then each one after that is 4% greater. So this is one of those that doesn't happen in your head, but I will kind of use sort of a shortcut method. If you're not going shortcut, here's what's going to happen. We're going to have 60 and then 4%, 0.04 times 60. and we're going to get some answer. And we can type that in the calculator. But again, let's be realistic. Let's be really realistic. We have 100% of 60, and then we have 4% of 60. 104% makes 104%. That's 1.04. Our common ratio, before we even get too far into this, we know what it is. It's 1.04. All right? This will save us some trouble there. So now we'll just grab a calculator, and we'll keep multiplying by 1.04. It didn't tell us where to round the decimals, because it doesn't say we're necessarily dealing with money here. So 60 plus 62.4 plus, and I'm just going to write one more of them, so times 1.04 is 64.896. Okay. Add the first 20 numbers. So give me a letter, any letter. Okay, good. You gave me an A. I'm kidding. I have no idea what you gave me. A1, A2, A3, and this is going to go on forever until we get to A20. So it didn't really go on forever. That would be infinite. So it goes to A20, and we don't know what A20 is. Do we need to figure it out? If this was arithmetic, then the formula would demand that we figure out what A20 is. And we would have to use the explicit formula. Notice we've not done anything with the explicit formula here because we don't need to figure out a specific term. The only term we need is A1, which is normally given to us. So here we go. We're going to add these things together. Now, obvious question that I just said, is this an infinite sum or a finite sum? It is finite. Finite meaning it ends. And so here we go. We are going to add together the first 20 terms. 20 because they said so. And so here's our formula. I'm going to write it down just for fun. Man, isn't this fun? 1 minus r. I'm going to put that in parentheses on the bottom, even though it may not be that way on your paper. That'll help us in the calculator. So 61 minus 1.04 to the 20. I'm going to raise it to 20, and then 1 minus 1.04 on the bottom. And we'll type that in the calculator. Once we get that, we're done. Now, we're going to have some crazy decimals. For consistency, that's a hard word to say, we'll round it to 2 decimal places. So we'll go 61 minus 1.04 to the 20th power, and then we're going to divide it by 1 minus 1.04. And we have 1786.68. There we go, 1786. 68. There it is. So there's the second one. So now, some of the rest of the ones on the front of the paper are going to deal primarily with finding out what n is, or using this in conjunction with the summation formula. And actually the first two on the back side deal with that as well. So we're going to go through those separately in a separate video. So I'm going to stop this video, and then you can go to part 2, and then you'll have those, and then part 3 will start about a third of the way down the back side.